What we've done so far with vectors is we have looked at what they are. We have done some addition with vectors. We did that geometrically. We did that algebraically. We did subtraction with vectors. We did that geometrically. We did that algebraically. We did multiply vectors by a scalar, and that just, if the scalar's not 1, that will adjust the length of the vector. If it's a negative number, it's going to also change the direction of the vector. So we've done that. What we are missing at this point is multiplication of a vector with another vector. And the thing about multiplication of vectors, there's 2 ways to do it. So the dot product is one of them. So I'm going to start off and say multiplication of 2 vectors. And there are 2 ways to do this. And one of the ways is called the dot product. And that's the topic for 12.3. And the other one is the cross product. And that's 12.4. So we'll be doing that tomorrow. Are there only 2? There may be more. That's 2 we cover. Okay, so I'm thinking you probably know something more than this. So, all right. So these are the 2 that we cover, the ways to multiply 2 vectors. And so the dot product, I'll give the definition of this. The dot product, if we have vector A and vector B, so if vector A equals this vector, I'll give it in 3 space, so there'll be 3 components, A1, A2, A3. It works for 2 space as well. So if vector A has those components and vector B has B1, B2, B3, then the dot product, and we'll write it A, vector A with a dot, vector B. Here's how we'll denote it. It's going to be this. A dotted with B is going to be a scalar. You're going to get a number, and it's going to be A1 times B1 plus A2 times B2 plus A3 times B3. So whatever that number is, there's the dot product. And again, it is a scalar. So I'll put that on the side. You get a scalar. When we do the cross product, which will be tomorrow or later this week, you're going to get a vector. So that's kind of worth noting here, that in 12.3 we're getting a scalar. And in 12.4 you get a vector when you do the cross product. So